So I said before when I was talking about equivalent fractions, if you can multiply both the top and the bottom by something, it stands to reason you should be able to divide both the top and the bottom of a fraction by something. Now, there is a point at which you can't find anything else to divide the top and the bottom of that fraction by. We call these we call this fraction in lowest terms. So for instance, if I had 2 and 3, if I had the fraction 2/3, and I'm trying to look to see if there's something that evenly divides both 2 and 3, well, I could think through my list of multiples there, but 1 is the only common multiple here. It's the only thing that divides 2 and it divides 3, but dividing both the top and the bottom by 1 doesn't really do much. And so it's kind of a waste of time. So when a fraction is in lowest terms, that's the same thing as saying the greatest common factor, the biggest factor that's in common for both of these is 1. That's the only thing that's in common between them. We just call that the greatest common factor. So if we had something like 30 over 48 and we wanted to write it in lowest terms, we need to start thinking through, okay, what are the common factors here? It is possible to start, to write a complete list of all the factors of 30 and a complete list of all the factors of 48, figure out which one of those is the biggest, divide it out. That was one way of going about this. But usually the easiest way to approach a problem like this is to just spot a common factor and just start from there. So I can see right away that these are both even, which means they both have 2 as a factor. So if I take and divide both the top and the bottom by 2, I get 15 over 24. Now this might be in lowest terms. It definitely is an equivalent fraction. They're the same numbers because I just divided both the top and the bottom by 5, but it might not be in lowest terms yet. So I need to look at this and see, okay, can I make these numbers any smaller? Well, the top number is not even, so 2 is not a common factor. But that doesn't necessarily mean that there's nothing else. And actually 3 is a common factor. So I can take and divide both the top and the bottom by 3. And that gives me a 5 up top and an 8 down below. I actually recognize 5 as one of my prime numbers. It's nice to notice when something is a prime number because I know that its only factors here, 1 and 5. The only factors of 5 are 1 and 5. So the only way I can reduce this further, well, you can see 1 doesn't really matter. I don't really care that 1 is a factor, because dividing by 1 isn't going to change anything. The only way that this could be divided down even further is if 5 was a common factor. So if clearly 5 is not a factor of 8, which means that there are no common factors here. I don't even have to look at the factors of 8 beyond recognizing that 5 is not one of them. Now, take 8 divided by 5, you can see it doesn't come out nicely on the calculator. 8 divided by 5 is 1.6. So you can see that 5 is not a factor of 8 there. So when we take 30 over 48 and we reduce it to its lowest terms, we get 5/8. It is possible, sometimes it's nice actually to do this using the prime factorization. So let's talk about the prime factorization for a second. The prime factorization of 30, well, this is a way to write 30 as a product of a bunch of prime numbers. You can do this in a couple of different ways. You could use a factor tree. You could say 30 is equal to 2 times 15, and 15 is equal to 3 times 5. Therefore, 30 is equal to 2 times 3 times 5. That's a perfectly valid way of going about this. I personally am not the biggest fan of factor trees because they just take up a lot of room and they make things look a little cluttered sometimes. Instead, what I like to do is I like to start off with my number, 48, on my calculator, and think through my prime number list. Well, the very first number on the prime number list is 2. And it's really easy to see if something is divisible by 2. It's just if it's an even number. 48 is divisible by 2. So what I'm going to do is I'm going to divide out 2, and I'm going to write down 2 as a factor. So now what I have is 24. Whatever's written here, whatever's left over here, is going to be equal to 24. I've written, 48 is equal to 2 times 24. So now I've broken this down into finding the prime factorization of 24. Well, 24 is even, which means 2 is a factor, so I'll do 24 divided by 2, and that's going to be 12. And you can see this is a very recursive process. Now I'm going to say 2 times, well, whatever's left over written here needs to be equal to 12. Okay, well, 12 is an even number, which means I'm going to divide by 2 and say, write that down, and say whatever is left over here is going to be equal to 6. 6 is still an even number. I'll take and divide out by 2, and 2 times whatever is left over here is equal to 3. So that's equal to 6, 12, and 24. Well, 3 is actually a prime number, so there I'm actually done. I was actually able to do 48 just by looking at 2's. This is certainly not going to be always the case. Oftentimes you're going to end up with something that's not a prime number, and you're going to have to move on to 3's and so figure out if 3 is a factor. And if 3 isn't a factor, maybe move on to 5's and then 7's. You know, I'm just working my way through my prime number list. 2, 3, 5, 7, 11, 13, and so on. Frankly, this, as short of a list as this is actually usually long enough to get quite a bit done. If you're looking for the prime factorization and you're all the way up through 13, you know, you checked all of these and you've seen that none of those are a factor of it, and 13 is not a factor of it, then actually, if your number is bigger than, actually, let's see, 13 times 13 is 169. As long as your number isn't bigger than 169, you can actually conclude then that that number would be prime. So for instance, if I was trying to find the prime factorization of 91, well, I would try 2. That's 2, 3, oops. 2, 3, 5, 7, 11, 13. Okay, so let's just try the various numbers in this list. 91. Oops. Yeah, apparently I have the calculator open multiple times. All right, we'll do 91 divided by 2. Of course, it's not even, so it's not divisible by 2. So let me just cross that one off. Having window problems. There we go. Try and divide it by 3. Well, I can tell using my divisibility test that this isn't divisible by 3. 9 plus 1 is 10, and that's not divisible by 3. But also I could plug it in. You can see that's not divisible by 3. It's not divisible by 5 because it doesn't end in a 0 or a 5. It might be divisible by 7, though. Let's go 91 divided by 7. And hey, it's actually divisible by 13. Sorry, it's divisible by 7, and it's equal to 13. So this is equal to 7 times 13. So I may have thought that 91 was a prime number when I was beginning this, but by going through my list of prime numbers, I was actually able to find 7 as a factor. I just wrote 13 down because I know 13 is on my prime number list as well. So 7 times 13 would be the prime factorization of 91.